Hello my dear students, welcome to my YouTube channel Shiv Academy of Mathematics. So dear students, in today's video I am going to discuss one of the important topic of this complex analysis which is useful for all these B.Sc classes, B.Tech and M.Sc. And the topic which I am going to discuss is Cauchy-Riemann equations in polar form. So dear students, I am going to discuss how we can find the CR equations, or what you say Cauchy-Riemann equations in polar form. So what we have to do, we start by taking this let z equal to x plus iota y, and you know very well that the polar coordinates are r theta and the value of x is r cos theta, y equal to r sin theta. So when we have to find the CR equations in polar form, what we will do, we put x equal to r cos theta and y equal to r sin theta. So what you get, therefore z is r cos theta plus iota r sin theta. So if you take this r outside, so you get r cos theta plus iota sin theta. And when we apply the Euler theorem, so you get it r e to the power iota theta, because by Euler theorem e to the power iota theta is nothing, it is cos theta plus iota sin theta. So this is the value of this z, means to say you can write z equal to r e to the power iota theta. So this is the value of z in the form of r and theta. So now what we have to do, we know that we take this f as the function of complex variable z as u plus iota v, fz as u plus iota v. So you know very well that this value of z is r e to the power iota theta. So we put this z equal to r e to the power iota theta here. So what you get, it implies f of r e to the power iota theta is equal to u plus iota v, is equal to u plus iota v. So what you get from here, u plus iota v is equal to f of r e to the power iota theta. So what we do, we take it as 1. And dear students, what you have to do, when you have to find CR equations in polar form, you will differentiate this one partially with respect to r and second partially with respect to theta. So what you have to do, you have to differentiate this one partially with respect to r as well as theta. So what you get, you will write differentiating one partially with respect to r. Why we are doing it as partially differentiation? Because this f is depending on two variables, r and theta. That's why we are taking the partial derivative. So when you look at this, it is f dash r e to the power iota theta, and derivative of r e to the power iota theta with respect to this r. So that will be e to the power iota theta. So this is the left side. We differentiate f with respect to r, and then we differentiate this inside term with respect to r. So you get this e to the power iota theta. And what about the right side? It is u, it is v. So that is curl u by curl r plus iota curl v by curl r. So we take it as 2. So we take it as 2. Now we differentiate this one partially with respect to theta. So we write here differentiating one partially with respect to theta, we get. So now you differentiate this with respect to theta. So again, derivative of f, this f dash r e to the power iota theta, and derivative of r e to the power eta e to the power iota theta with respect to theta. So r is as it is, and derivative of this e to the power iota theta is what? Iota into e to the power iota theta is equal to curl u by curl theta plus iota curl v by curl theta. So now what we do, if you look at the number 2, we are having this f dash r e to the iota theta into e to the power iota theta equal to curl u by curl r plus iota curl v by curl r. So we put the value of this whole value in this. So it is f dash r e to the iota theta into e to the power iota theta. So using 2, we can take it as 3. In 3 we get, so what we get, so when we substitute r iota as it is, r iota, and the right side is, it is curl u by curl r plus iota curl v by curl r is equal to curl u by curl theta plus iota curl v by curl theta. So you just multiply this iota in this inside. So what you get? It implies r curl u by curl r iota square, which is minus 1. So it is minus r curl v by curl r is equal to curl u by curl theta plus iota curl v upon curl theta. So what we do, we equate real part and the imaginary part. So we are writing here equating real and imaginary parts. We get, so when you look at the real part, it is curl u by curl theta equal to curl u by curl theta is equal to minus r curl v upon curl r, and when you equate this imaginary part, so it is curl v by curl theta, and the left side is, it is r curl u by curl r. So dear students, finally what you can do, you can write it in this form. You write curl u by curl r is equal to, so we take r to the left side, it is 1 by r curl v by curl theta, comma, and when we see here, it is curl v by curl r is equal to minus r in the left side, so it is minus 1 by r curl u by curl theta. So these two equations are CR equations in the polar form. You know very well that when we talk about CR equations in Cartesian form, ux equal to vy and uy equal to minus vx. Or what you say, curl u by curl x equal to curl v by curl y, or curl u by curl y equal to minus curl u by curl x. But in this, we have find out the CR equations in the polar form. That means to say in the form of r and theta. So problem is very simple. We start by taking z. We put x equal to r cos theta, y equal to r sin theta, and then we compute fz, and we put here z equal to r e to the power iota theta. And what we have to do, we have to differentiate this one partial with respect to r as well as with respect to theta. And when we substitute number 2 in 3 and we equate real and imaginary parts, you will get the CR equations in polar form. So dear students, hope so you understand the CR equations in polar form. So don't forget to subscribe our YouTube channel Shiv Academy of Mathematics. Thank you.